Hey, good afternoon, everyone. Thanks for being here. I know we just had a lunch, and it takes a little while to get back in the game. But I hope we are all here, and I hope this session is going to be useful. So I am Muneer. I'm a data scientist working as AI solutions architect at NetApp. Today's session is going to be about data-centric AI. Right? So we all have been doing AI, machine learning, deep learning now from years. Right? The big boom started in 2012 with AlexNet. But what is holding us back to see the same pace what we have shown so far in the research and get that into the production and make AI mainstream? So we'll be discussing some of the challenges and some of the solutions that NetApp has been working with the customers, with the partners to solve those challenges. So we know that AI being used in almost all the industry. You just name it, right? Manufacturing is there, automotive vertical is there, healthcare is there. In some capacity, we all are trying to get AI into the game, and due to good reasons, like to automate a lot of things, which takes a lot of time, as well as kind of target the verticals as well as sectors which were difficult to kind of utilize the best out of our existing data. As per the IDC Customer Insights Analysis report, a few years back, as I mentioned, we were just stuck in the POC phase. Now we have moved well beyond that. So that means investments are there, right? And we are hiring new talents that are very much talented, and they know how to get best out of the data, which were not possible sometime before. Coming out of universities, as well as getting some experience while they were in the universities, working on some projects. Now, industries are trying to get that talent, get the data that they already have, and make some noise around it and get the return on investment that they have feed into this domain. But still, the problem is that 87% of the project, of one report, 87% of the projects still don't see the daylight. And may I ask the audience, like, do you have any idea, like, why do we have this problem in the space? Like, most of the projects don't go into the production. Any thoughts, any ideas? Please go ahead. It's hard to? Python is hard to deploy. OK, deployment issue. Any other issue? Go for it. Bad code. Bad code. Yeah, data scientists are not software engineers. Yeah, I heard that a lot. And any other thoughts? Security, exactly. Big threat, because we are talking about data, right? And we are not, let's say we cannot take any data, work on it before making sure that we are not exposing it to some security threats. Whether that's on premises or in the cloud, the story is very much similar. Let's say we are designing some algorithm today in fintech, for example. And that's being used, that's using the customer information, transactional information, and we release that model into the production. OK, we don't have that data in the production, but we release that model in the production. And are we certain and sure that this model is not going to expose any personal information unintentionally to outside the world? Are we certain about the fact? I don't think so, because we can reverse track back the results and see at least the geographical location where my model is seeing more, let's say, signals, right? So that means most of the customers were from that region. Just one example. And also, when we upload our data to the cloud, for example, data scientists like me, I don't care how that's been imported there. I just want to use it. And accidentally, I might expose that to the public unintentionally. And anyone can access that data, right? And so I'm going to focus mostly on the, as I mentioned, data-centric part of the world, right? As you mentioned, deployment is one of the challenge and other things associated with it. But the talk is going to be focusing on the data itself. And data can be anywhere, right? We can get the data in real world, let's say streaming, right? Our cars, IoT devices, medical apparatus, you just name it. So you have that data coming in into real time. And we have historic data. That's in the core, whether that's in cloud, on premises. And we try to mix both streaming as well as the legacy data that we have, because we want to get max out of our existing data and the new that's coming in. And it can happen in cloud or core. Right? Core means data centers that we have, workstations that we usually use to develop our concepts. Now, when we move data back and forth, privacy, confidentiality, security, these are all the challenges that come into the picture. And when we start a project, as a data scientist, I usually go with a proof of concept, just to prove that hypothesis works. Makes sense, because if I try to use all the data, first, it takes a lot of time, and second, I don't know whether it's going to solve it or not. Now, at that point in time, later on, we scale, or we go to the deployment, into the production, then this nightmare comes into picture. Like, where does that data came from? Who was working on that data? Who owns the data? All that issues, because auditability team tomorrow comes into picture, and we don't have any answers. Code is there, data scientist is there, but I don't know what pre-processed version of the data I use, right? So these are only few. I'm just touching the tip of the iceberg. So a lot of challenges are associated with the data itself. That's what gave rise to the data-centric AI. And yeah, linearity we were thinking about previously, like it should scale linearly, right? We should take care of it when we go to the cloud. We should take care of it when we go from 1 gigs to 10 gigs to 10 terabytes to 10 petabytes. But in the later stage, it's difficult to track back all the steps that we did and kind of create some production-grade AI solutions. And yeah, this should not be new to anyone, that it's all across the industries, that everybody is thinking about it now. Like, how do we properly take care of these issues? Now, usually, when we talk about AI projects, it's a little bit different from software 1.0 world, where we use to develop the code, and we create artifacts, deploy that artifacts into the production. Now, with AI, we need to be a little bit creative and innovative. So, of course, with the software engineering 1.0 or software 1.0, we start with some conceptualization, develop the idea. But in AI, it's a little trickier. Like, how do we define the KPIs? Depends from person who do you ask. Like, if you ask someone, hey, you need to solve a problem in medical imaging, for example, where we are trying to figure out that particular scan is having tumor or not. So if you ask that question to the data scientist, what is going to be his answer? Like, defining the KPIs, key performance index. Like, how do you monitor the model? What's going to be his answer? Anyone from the audience? For example, I'm going to say, like, if my overall score or the accuracy of the model is 90%, this is good enough as a data scientist. But how do I transform that, and how do I inform my business units that the model is performing well enough for the business itself? Because they don't understand 90% accuracy, ROC, AUC, those kind of things. Now, how do we transfer that information? So that all comes into this ideation phase. So it's not just about creating small POCs, but defining those business values. And then the second stage is creating itself. Like, do you have enough, let's say, infrastructure for that? Do we have a talent to get started? And when I say talent, it's not only about data engineers, data scientists, but subject matter expertise is more important. Until unless we do not understand what exactly is important for the subject matter experts, again, medical healthcare, if we don't understand what makes sense for the radiologists, we might not be able to provide them the models at the end of the day, which makes sense for them. Because for us, accuracy, as I mentioned, accuracy is a great thing. But how do we translate that information? So that comes into the creation phase. Still, we are in a POC stage, right, proving our hypothesis. But when we go to the validation phase, we need to train at scale. We need to train whatever data we have at our disposal, whether that's on premises, in the cloud, or we are acquiring that in the real time. Now, the challenge. Again, who is owning that data? Do we have auditability in place? How do I share that data with my colleagues later on when it grows, right? Because multiple data scientists, multiple data engineers can be working on that particular problem. And then the interpretation. Nowadays, you'll see more and more policies coming into picture that are asking us, can you explain why your model is behaving the way it's behaving? Let's say if we are using that model for loan approval or rejection. So tomorrow, someone might come to us that your model is biased. It's approving more loans to males because you have a lot of data about the males, but rejecting a lot of applications for the females. Can we prove that it's not the case? It's unbiased. So that comes into the interpretation. We need to have that linkage back. What data was used? Kind of a time travel. Can we do so? And finally, the deployment phase. Like we just, one gentleman commented earlier, Python is difficult to deploy. But do we have some strategies to scale it up, to scale it down? And do we always have to, when we create a model, it's kind of a unified process. Next time, let's say today I'm having a computer vision model. Tomorrow, I might be having time series data, which I have trained my model on. And then afterwards, it might be some other, like the structured data, tabular data. So can we create some kind of unified solution where I just take a model, plug and play, and it will give me my inferencing results, tie up back to my application, whether APIs or some other means of integration that we want to achieve. So this is the normal process that we have been working on, did research, as well as our customers are using, that these people go through. Now, ultimately, the goal is to have this pasta on plate, right? And to serve it to the end users. That's where the challenge of 80%, 87% of the projects, as I mentioned earlier, fails are because they don't take these steps into consideration while they get started. Later on, there are a lot of things which we cannot track back. And from the NetApp side, we take these things seriously, and we have been in the business almost 30 plus years. We were mostly focusing on storage and data management. And from 2018 onwards, we transformed our whole product portfolio and kind of linked it with what are the processes involved in whole AI lifecycle, and how do we make sure that the data operations that are needed and associated with these machine learning, deep learning projects, how do we eradicate the challenge as much as possible? And what we did is we target all the data points where data can be available or can be collocated and collected. That starts from the edge, as I mentioned. You have some base stations, you have some servers that are at the edge side where inferencing is happening in the real time. You might be having some historic data. That's in the core in our data centers. And you might want to quickly try some POC in the cloud, later on get back on premises. So we provide a unified experience so that data scientists don't waste their time on these things like security, privacy, confidentiality, tracking of models, like traceability, what data was used, and sharing that, collaborating with a fellow data scientists all across the globe, not just at one particular site, but if it works on my workstation, same thing should work on the cloud, same thing should work globally wherever my colleagues are located. And what we designed so far for the data scientists is that's called NetApp Data Ops Toolkit. And some of the partners we integrate with as well. NetApp Data Ops Toolkit is an open source solution. It's a Python-based library, so most of the data scientists are familiar with the Python. So for them, it's just one pip install Data Ops Toolkit. And they get all the good features that are incubated inside it. And what are some of the features that we have? Is that, I'm going to skip this slide because it's just showing us the general process of the AI workflow. Is that we can be working on the projects, let's say on a workstation, right? But same project, if we want to scale it up tomorrow, we might want to use some technologies like cloud-native Kubernetes, where scaling up, scaling down is pretty easier for us, as well as deploying the models wherever you want. Like create a containerized solution, and you don't need to worry different versions of Python that maybe I'm using Python 2.7, which is now obsolete, and my colleague is using Python 3.7 or 3.8. So we don't need to worry about those things. So what we saw so far, that containerized approach works best, but it comes with its own challenge. Let's say data scientists, they're not getting paid to learn DevOps. Now, how do we make it easier for them, right? And provide them the means and the platform that they're comfortable with. So we work with some MLOps solutions, for example, Kubeflow, MLflow, Apache Arrow, and others to incubate the features that were missing from the data management side of the world. And that's where comes into picture NetApp Data Ops Toolkit. And NetApp Data Ops Toolkit, very superficially, some of the key capabilities that I'm highlighting here are that you can take a version of your data as easy as you're taking version of your code. For example, using GitLab, Bitbucket, GitHub. Very much similar concept here with the data. You do not need to copy data, first and foremost, because security is important. But at the same time, it will take a whole point-in-time capture of your data within fraction of a second. You don't even realize, like terabyte, petabyte scale data, snapshot is there. Tomorrow you want to go back to that previous state, within fraction of a second, you'll get that state back. And also sharing. Like when we usually share, how do we share with data with our fellow colleagues? Anyone here? How do we usually share that data? If we have to work with our data scientists, data engineer guys out there. How do we share it? Any thoughts? Sorry? CSVs, but how do you give that CSV to the particular data scientist, data engineer? Pen drive, right? And anyone else? Like we also do SCPs, right? Right? We copy it like using the secure shell scripts, and we copy it that way as well. But the problem with that is we are creating silo. Like the copy that you're having with your CSV in your pen drive, I might modify it, and you don't have any information about that. Right? So we break the lineage. So why don't we have some kind of concept like in a code we create branch? Why don't we create a branch with the data as well? And so that you can tomorrow track back the original copy of the data, where that data was taken from, and someone worked on that. So that's what we are giving with the help of NetApp Data Ops Toolkit, cloning feature. And we don't create copies. We only store the change that is going to be taken place if someone is going to modify that. And also, what we have so far realized is that when we train our models, we store the data, training data, in some fast and efficient storage because our GPUs and CPUs are so demanding that it can choke the processing power of the GPUs, and we had to wait in a queue. So, but later on, when the training is done, we don't need that kind of efficient storage all the time. So why don't we tear this data, or why don't we move this data to some affordable storage like object storage, S3? Nowadays, mostly popular because of metadata tagged inside it. Challenge is that as a data scientist, I don't want to learn somehow S3 works, right? Data engineer mostly work on that, but I don't like it. I just need my data raw, maybe in terms of some serializable form, right? So that it's fast to load later on, and I'm going to do my training on that. So taking that into consideration, what we did is we inculcated that feature in the game as well. Now, for the data scientist, it's just calling one API call of the Python, and it's going to send the data to the object storage. Later on, they want it back because they have a key associated. It's just asking, hey, I just want to pull this data back, and it will be available without being aware of the fact that it's going to some object storage, something is happening. For them, the storage is available to kind of store the fast and efficient, to store the data that's going to be needed for fast and efficient training. And just giving you an example, like the cloning feature I mentioned earlier, the sharing. So this was one test that we did, that we tried to copy 10 terabytes of data. And usually the simple copy, either like, let's say, some external media or some SCP kind of command, within the setup only, it took almost 17 hours. And with the clone feature, just 2 seconds, and it was there. So data scientists, like me, I used to say, hey, I'm going to grab a coffee because my data has been copied. So we are trying to eradicate those kind of problems, which looks like there is, it's part of life. But we are trying to think from the other side of the world that we can solve it to some extent. We can give them more time. They want to work on these problems. And also, apart from the data, we are right now kind of using some kind of processing engines or distributed frameworks like Spark. So do we have some solution for that as well? Someone is going to manage that for us. So we have managed solutions as well in services. Not just on premises, it works in the cloud as well. In cloud, like someone is paying at the end of the day. It's going to someone's credit card. So we are trying to reduce that workload automatically. Let's say in cloud, our product, this is called Spot. Why Spot? Because in cloud, you have Spot instances. Treat them as preemptible instances. Like if you run your job and someone else needs that instance, you'll be kicked out. So we leverage that in our favor in a sense that once you start the job and afterwards your job is kicked out, it will automatically use some other instance intelligently, provide you more time so that you don't have to manually go from one place to another place. And we have this for the Spark and some other frameworks as well. Like you have Cassandra databases. It's for that as well. Kafka streaming engines. We have it for that as well. And some other services in place. For whole data engineering as well as data science side of the world. And we work together with our partners like NVIDIA because, to be honest, AI is not one army kind of show, right? So we need to have an ecosystem. We mostly focus on the data management piece. And for the compute side of the world and some frameworks, we work together with the, NVIDIA. And we have created some reference architectures together with them. And when I say reference architectures, it's not just tested and vetted in labs, but we have a large customer deployment all across the globe, and that are very happy. And we take those feedbacks into consideration and improve it, the whole infrastructure, as well as the APIs, plus the frameworks that are used. And apart from that, compute partners, we work with other partners as well, like ISVs. Some of them are here today, consulting partners, as well as Channel, Cloud, and Colos. With this, I would like to thank you all for your time. And I know it was difficult after lunch being here. But thank you so much for being here. Have a nice one. Any questions? Yeah, please go for it.
Thank you for the presentation. In one point, you said that you can go back to historic state. Does that mean you can back to a historic state snapshot, or are you doing something like event sourcing and I can go to any possible historic state?
What we do is we create a snapshot of the data itself. So if you are using, let's say, 10 images today, and you trained your model on those 10 images. But then tomorrow someone modified one image, deleted one image, or more images were included. But you had a trained model on those 10 images. So what we do, we make sure that you go back to that instance of the data with the 10 images that you use for the training. So that's what I meant, point-in-time capture of the data. Does it answer your question?
Yes, it does.
Thank you. Any further questions?
How does the fact that you can go back to a previous snapshot of the data fit with the fact that if you have data on people and it's personal, they can require that it is removed from your data set?
Perfect. So the question is that how do we make sure, like, if we now want to delete that data altogether, and we don't want the snapshot feature there because we want to delete it, right? So you have the capability as well to do so. So you just have to remove the snapshots, and whatever data was used is be gone. But that needs an administrative right permission because we want to have immutability in place. But if you force it, you can do that as well. That's included.
Is there some trace left that, I mean positively, that there is a change made, and so the results are going to be discontinuous? Yeah.
That's right, exactly. So if we force the snapshot to be deleted, now the data is not there, so the trace or the lineage is gone. So that's why we force to have administrative rights if you really want to do that, which we usually don't give to data scientists, data engineers. It's going to be someone, let's say, head of data science. Let's say that project is discarded. We don't use anywhere those models. We don't use their data anymore. Now they know why they want to delete it. That means we don't need immutability there as well. But you're right, data lineage is gone once you delete it.
Any other questions? Okay, let's thank the speaker one more time.
Thank you.